Before I introduce you to the use of the switch statement, we're going to write a small application that uses if statements initially to build a small calculator. Then we will improve upon this application with another file or another program that will use the switch statement. And we will compare both techniques to see which one you like best. Okay? All right, so let's say I want to build a calculator that can add, subtract, multiply, and divide. So 4 functions, nothing fancy. That's what I want to do. And so what I'm going to do is I'm going to need these operations to be done on 2 numbers. Enter number 1, enter number 2. Then that's after you select which operation you want. You want to add, you want to subtract, you want to multiply, you want to divide. So I definitely need 2 variables, double, num1, num2, and maybe store the result right here. Okay? All right, so now what I'd like to do is display on the screen the actual menu that I would like to have. Okay, so maybe something like this, see out. And now I'm going to use some escape characters to center the menu a little bit to the center of the screen. /t, /t, /t. /t gives me a tab, by the way. I just need 2 of them. And I'm going to call this one calculator menu. And then a /n to give me a new line. Close the quotes, so that's one string that will come up on one line. Notice I don't put a semicolon there. And I am going to continue on with a /t right under it. And then put an underline here, just to make it cute. And then do a /n again. And then go to the next line. And put in my choices as to what I want. So /t. If you pick 1, that will be an addition. /n. And then I will do this. /t. Oops. Don't forget the quotes. /t 2. This would be a subtraction. /n. No semicolons. I'm continuing with the same stream here, right? And I'm kind of formatting it the way I would like it to look on the screen. /t. If you pick 3, that would be a multiplication. /n, and then finally the division. So /t 4, that will be division. /n. Now let's suppose you didn't want to pick anything, right? So /t maybe 5, simply exit, which means you ran the application, you really don't want to do any operation. That's fine. /n. Next one will be go ahead and enter your choice. So, and I'm just going to put 1 /t here, enter your choice. So I am going to need an integer value to store 1, 2, 3, 4, 5, or any other integer value you enter. So I need 1 extra variable. Well, I'm going to declare it in the declaration block right here. Int, and let's call it choice, right here. So now I'm going to ask the user to enter it. So cn choice. Let's compile this program quickly to show you how it looks like, how it works. So let me compile and run. As you can see, it shows a menu. Let me just go ahead and make the properties a little bigger here. This time I'm just going to pick 28. I don't want to make it too big. Okay, so as you can see, what I've created here is a menu. Okay. And the /n's at every end of the line just gives me a hard return. And everything was within the same output to the screen up to where it's blinking. That's my CN waiting for the choice that I want. And then You can enter any number you want and then press any key to continue. Now, if we were to use if statements to make sure that we're within the range of 1 through 5, we could do what we call entry validation or data entry validation. That probably is a good idea right from the get-go, which means right from the beginning, you will only filter in valid values, 1, 2, 3, 4, 5. So that means you need to filter out any invalid values. An if statement comes in handy for this. So you could say something like this, like the previous example we've done. If choice is less than 1, which means you picked 0 or a negative number, or choice was greater than 5, right? So that means you picked 6, you picked 7, or any other value, then print an error. Cout invalid error, invalid choice. Now let's see if that works. And let me just put an end L here. All right, so let's run this thing. Compile and run. And I'm going to enter 0. So let's see what it does. Invalid choice. 0 is not on the menu. Okay, let's run it again. And let's pick 6. And again, invalid choice. Now, if I pick a valid value, nothing will happen because the if statement is false, right? The expression under the if statement will be false. So if I pick 1, nothing happens and your program ends. Can I do the reverse? Can I do a reverse where if your choice is not within a certain range, then print an error, which means you could reverse your logic here. Just good lesson here, what we can do. What else can you do? If choice is not, and you could put your range here. Choice greater or equal to 1 and choice less or equal to 6. Okay, this is another way to do it. This here is a not, right? So what it says is this here is where you want to be. But if you're not there, this is what the not is, print invalid choice. Well, let's see if it works. So let's go ahead and compile and run. And let's say I pick 9. Invalid choice, indeed. So let's say I pick -1. Invalid choice as well. Let's say this time I pick 5. No answer, which means everything was fine. This is one way to do it. Can I do it in another way? Yes, you could do this. So if you don't put the not, let's say you take it out, then this would be valid choice, and then you need an else. Else, cout, invalid choice. So you can see the flexibility in your design as to how you can drive the logic, right? So as long as choice is between equal to 1 or greater and equal to 6 and less, it's a valid choice, right? Else, now you could see this, I have to use an else to show that I have an invalid choice. Let's see how this works. So compile and run. And let's say I pick 2. Valid choice. Let's run it again. And let's say I pick 8. And I will get invalid choice. So this is your filtering process for data entry validation, at least what's listed on your menu based on ranges. Now, what else can you do? Well, now, if you're going to be in the valid choice range, you can do a whole bunch of things. So I'm just going to put a curly, I like always put curly braces here, just in case I have multiple statements in the true block, which means you're going to be here only if, indeed, you had a valid choice. What valid choices you might have? You might have 1, you might have 3, you might have 4, or you might have 5. Aha! Can we do something with those? Yes. So we could go backwards, we could go forwards, whichever way you want. You could start from 5 or you could start from 1. So for example, if choice equals 1, now you have to be really precise. So maybe see out for now, addition operation. Okay, so I'm just showing that that's what we're doing. And I'm not asking for the numbers yet. I'll handle that in a minute. Else, we're going to do a nested if statement. If choice equals 2. So that means if it wasn't 1, is it 2? If it's not 2, is it going to be 3? If it's not 3, is it going to be 4? If it's not 4, is it going to be 5? So we are simulating what we've done in example 24, where we had a nested if statement within the true block of the first if statement. Okay, so we're just driving our logic. So if the choice is 2, then go ahead and see out. For now, I just want to display what mode I'm in. Subtraction operation. And I will do the subtraction and everything else, or any other operation, once I know that my logic works. Okay? Don't try to make things complicated first. Just make sure everything flows, everything checks itself before you actually get into the meat of coding. Yes, we are coding, but we're setting up the framework for our logic to be nice and tight. So choice equals 3. 3 was for multiplication, so see out. And that would be multiplication. And L. Okay, what else we have? Division. Else. If, notice the tabbing. So you could see which else belongs to which if. Very important. Okay? Choice equals 4. And under that one, we have the division operation. And let me just write down multiplication operation. And here, this one will be division operation. Else, neither 1, 2, 3, 4 were true. You're at 5. You have to be, because you're within the range. I made a mistake here. This should not include 6. Less than 6. Or if you want, you could say less or equal to 5. Okay, that was a big boo-boo right here. Everybody, I hope you paid attention to that. Okay, you want to include 5. So 5 is within the range. So, see out, which means I am at 5. Say something like this, goodbye. That's the end of the program there, so end L. Now let's try it out. Let's try it out and see if we get these headings: addition operation, subtraction operation, multiplication operation, or division operation, or the goodbye, based on the choices we pick out of the menu. Okay? So let's compile and run. Okay? Now let's suppose this time I pick 6. It should kick me out and says invalid choice. Now let's pick 5. Okay, so I'm going to enter 5. And sure enough, it checked every if statement. None of them were true until the end. Right? So the last if statement where choice equals 4 was false. That pushes the goodbye out to the screen. So let's run it again. Let's see if it selectively filters out everybody else out if I pick, let's say, 3, multiplication. And sure enough, it zeroed in on the multiplication operation, filtered out everything else. So in essence, it's working just fine right now. Great. So what can we do with this? Well, now we get to work. We can ask the user to enter those 2 numbers, right? And then we can do the operations. There are several ways we could do this. We could ask for the user to enter the operation, to enter the 2 numbers right here, knowing full well that you've already picked an operation. But that would be a problem. What if you picked 5? Then you're here. So maybe we could change the logic for 5. Right? So we could change the logic for 5 a little bit. And maybe here, we don't need to say goodbye. Watch what I'm going to do here. I'm going to change logic a little bit. Okay? So if it's 4, it's division. And I'm going to do the goodbye right at the beginning. Right here. Okay? So we could do that right here if that's what you picked. And which means we need to get out of this if statement, if possible. So we don't have to evaluate any of these, and we could break from it. Okay? So you could do something maybe where you evaluate up to 4, knowing that you're going to be doing operations. Else, and then we're going to do an if statement here. If choice equals 5, then go ahead and print cout. Goodbye. And L. Else, notice now, that means I have anything but 5. Now let's see if this does make any difference in terms of our logic. So let's compile and run. And let's pick 2. So 2 subtraction is good. Let's run it again. Let's pick 5. And it should say goodbye. So it's working just like before. Let's run it again. And let's pick 0. So that should be an invalid. Perfect. So it's not saying goodbye. It's not saying addition or subtraction. It knows 0 is not on the list. Let's pick something out of higher. And let's pick 6. Again, that should give us an invalid choice. So good. So we've handled the goodbye right here. This way, I can simplify my code and ask the user to enter the 2 numbers, right now, right before you do any of these if statements, knowing full well that you are within a valid range that you've picked. It means you are going to do an operation. So 1 to 4, somehow you're going to be doing an operation. So here may be a good idea to ask the user, cout, enter num1, then num2. We could combine them here. Oops. And then we do a cin, num1, num2. You put a space between them, that's how you separate them. So this allows me to enter my 2 numbers right when I know that I'm within the proper range. Okay? Now these curly braces must be there. They're no longer optional. Why? Because I have multiple lines now, not just a nested if statement, but actually multiple lines in the true block of your main data validation filter. Because I have a line here, and this is all, yes, considered one line, but I technically have 3 lines in this block. Okay, so now that we have the 2 numbers, depending on what we're doing, we could actually right here modify this, do a /n, and keep it all in one line, and then maybe print the result right here. Okay, so we could do the result operation right here. So you could do num1 plus num2 equals, and we could do the operation right here. Num1 plus num2. This is one way to do it. And L. I'll do different versions of this. So let's verify the addition works. Right? Notice here I did not use the result variable. I went straight ahead and added the 2 numbers right in the printout stream. So let's see how it works. Now I'll use different techniques for subtraction, multiplication. Definitely for division, I'm going to need another if statement to make sure the denominator is not 0. Okay? Otherwise, don't do that division. All right, but first, let's see what happens with just addition. So every time you add a feature, compile and run, test out the new feature before you move on to the next level. So let's compile and run. And notice I have 2 semicolons. That's why I get an error. It's fine. So let's go ahead and compile and run again. And there you have it. So I'm going to pick addition, knowing that's what's going to happen. Enter num1, then num2. So 2 space and 2.2. We can do that. So as you can see, 2 plus 2.2 is 4.2. Great. Now let's do the subtraction slightly different. For the subtraction, we're going to do several operations. So we're going to actually use several lines. If you can do that, put a curly brace here. And then make sure you close the curly brace here for the true block of this one. Why? Because I am going to do several lines within the true block for the subtraction. And I'm going to do result equals num1 minus num2, and then display result. So see out num1. So as you can see here, I have several lines when the choice is 2 versus when the choice was 1. All of that was a single line. So I didn't need those curly braces back then. Now I do. I have several lines under the if statement for choice equals 2. So we need to pay attention. That's why I have the curly braces, because that delineates the true block for choice equals 2, if it's true. So minus num2 equals, and then put the result, and L. Every time, stop, compile, run. Do not add more features to your program until you make sure that the algorithm you're working on is actually working. So compile and run. And let's go ahead and do a subtraction. Okay, so I have 2 space 4. So 2 minus 4 is minus 2. Okay, so it's working just fine. Notice the addition is still there, so I'm going to run it again. And I'm going to pick on the addition. And I have a 1 space 1. So 1 plus 1 is 2. Okay, now remember, these numbers can be float numbers. So let me go ahead and do it again. Let's do a subtraction. Let's say I have a minus 3.3 space and a minus 1.1. Okay? So as you can see, minus minus becomes a plus. 3.3 basically plus 1.1 gives you minus 2.2. Okay? So it's behaving just fine. Now, if you pick, for example, multiplication at this stage, as we know, we haven't done anything with it other than asking for two numbers, so 2 and 3, but we're just going to get the multiplication operation without any processing done. And the reason we haven't done anything other than displaying multiplication operation, right? But we know where we were within the proper range of choices 1 through 4 for operations, right, other than 5, and we were able to ask for num1, num2. So we need to continue with the code. So now it's a matter of choice. Do you want to do multiplication the same way we did addition? Or do you want multiple lines? Okay, I like this way. So I like to do it this way. And what I'm going to do is copy this part. And what I'm going to do is paste it right here. And just move this right here, line it up. And take this, do a big X for multiply, right? We know it's an, you could put an asterisk so you know it's a multiplication. And then the actual operator is an asterisk, okay? All right, well, let's see how it works. Again, every time you finish an operation, compile and run. Okay, let's pick on multiplication and see how it does it. So let's say we multiply 3 space by 3. Okay, and there you have it. 3 times 3 is 9. And again, it can do float values, right? So since num1 and num2 are float, and the multiplication of two float numbers is going to produce a float value. So, well, let's see that. Actually, you only need one of them to be float for that to happen. So let's prove that. So let's say we have 3. Let's say I have 2.3 space, and the other one is just simply 4. Okay? Right? So even though 4 looks like an integer, but this is really a float multiplication. The result will be a float. Okay? So we get our 9.2. Fantastic. So now, number 4 gets interesting because it depends if num2 is 0 or not. So what I'm going to do is delete this. Well, let's leave that in there. Let's put curly braces. We're going to do several things here. Right? So, and here we're going to do an evaluation. If num2 is not equal to 0, go ahead and do cout. And then go ahead and do your actual operation, or num1 divided by num2. Then we can do the operation right here. Equals, and then go ahead and do the operation, num1 divided by num2. So perfectly okay to do that. And then end L. Okay? Else, you could print an error and say you can't divide by 0. So cout error division by 0. You could tell the user exactly what happened here. And out. All right, well, let's see how division works. Okay, so we're going to compile and run. Let's go ahead and pick division 4. And let's say we want to divide 3 space by 2. And there you have it. 3 divided by 2 is 1.5. Let's try to divide by 0. So let me just run this again. And let's say, again, we pick 4 for division. And let's say this time I pick 2 space 0. Division operation, error division by 0. So you can't really divide by 0. So it picked it up. Okay? All right, so that was with nested if statements. As you can see, it can get very involved. Okay? Is there a better way? The answer is absolutely, especially when you have a menu-driven situation like this, where you have ranges, you have specific values. We definitely have a better way to do this. And the way we're going to do this in the next video is we're going to redo the same calculator we have here, but we will use the switch statement. Okay? So I'm going to redo the same exact application, but with a switch statement instead of nested if statements as you see it here.